In the summer of 1934, C. L. Farrar was managing research colonies at the Ohio Agricultural Experiment Station and recording a number that didn't make sense. One of his smaller colonies, a colony of roughly 22,000 bees, had outproduced a colony 3 times its size in the same apiary, on the same forage, across the same flow window. He didn't publish an explanation that year. He kept watching. He saw the same pattern the following season, and the season after that. By the time his research concluded more than a decade later, he had documented something the beekeeping industry quietly filed away and never widely taught. The largest colony in your apiary is not necessarily your most productive colony, and the reason has nothing to do with genetics, nothing to do with the queen, and nothing to do with the forage. It has to do with what the bees in a large colony are actually doing with their time. Most beekeepers have felt this at the end of a season. The colony you were most confident about. Strong all spring, frames covered in bees, full boxes going into the flow, and then a late June harvest that doesn't match what that population should have produced. The weather gets blamed. The flow timing gets questioned. Farrar had a different explanation. And it starts with a question almost nobody asks when they open a hive. If this kind of biology-first reasoning is useful to you, a like on this video helps it reach other beekeepers who are asking the same questions. And if you've ever had a strong colony disappoint you at harvest, leave a comment. You're likely not the only one. The question Farrar started asking was not how many bees does this colony have. It was how many of those bees are producing surplus honey right now. Those are not the same question, and the gap between them is where 11 years of documented research found its answer. A worker bee does not begin contributing to surplus honey production the moment she emerges. For the first 3 weeks of her adult life, she performs internal hive duties. She cleans cells, she feeds larvae, she processes incoming nectar through its early stages, she builds comb, she tends the queen. These are essential tasks, and a colony without enough bees performing them fails quickly. But none of this internal work produces extractable surplus. A bee doing nurse work is a bee the colony needs. She is not a bee producing the honey that fills the supers. At roughly 21 days, her internal biology shifts. Her hypopharyngeal glands begin to regress. Her flight muscles strengthen. She transitions into a forager, and for the remaining 2 to 4 weeks of her life she becomes the engine of surplus production, working until her wings wear out. This is the biology every serious beekeeper knows. What Farrar understood, and most beekeepers did not, was the implication it carries at the colony level. If a colony has more nurse bees than it has brood to care for, those extra nurse bees are not foraging. They are not producing surplus. They are eating the colony's stores and waiting out a biological clock they cannot accelerate. Farrar called this the idle surplus. Not a failing, not a disease, a demographic condition that develops almost invisibly in colonies above a certain population threshold, and that silently caps their production no matter how strong the forage is. Here is where his observation turns against the instinct most beekeepers bring to the hive. A large colony looks productive, bees covering every frame, bees festooning in the top box, bees clustered at the entrance. The natural interpretation is strength, and strength suggests honey. But the bees covering those frames are not all foragers. In a colony of 60,000 bees in midsummer, a substantial portion of that population has completed its nurse duties and is not yet, biologically, a forager. Or the brood nest has declined, as it naturally does during a summer dearth, and the nurse bee workforce that was correctly sized for the spring brood peak is now oversized for the reduced brood that remains. Those bees have nothing to nurse. They have not yet crossed into forager biology. They are present, they are eating, and they are contributing nothing to the supers. Most beekeepers never see this because the standard inspection doesn't measure it. You look at frames covered in bees and record strong. You look at a solid brood pattern and record healthy. Neither observation tells you what proportion of that population is engaged in work that produces surplus. And that proportion, not the total, was what Farrar's data consistently showed to be the variable that determined the weight of the honey house at the end of the season. Population is what you see. Efficiency is what produces. If this kind of distinction changes how you think about reading a colony, it may be worth subscribing. There is more historically grounded biology ahead on this channel, and most of it carries no price tag. The nectar processing chain is the clearest way to see what Farrar was measuring. When a forager returns with a nectar load, she does not simply deposit it in a cell and leave. She passes it to a receiver bee, a house bee in the early stage of nectar processing, who begins reducing its water content and adding enzymes. That receiver passes it further along. Eventually, the ripened nectar is moved to a storage cell and capped. The full chain from fresh nectar to sealed honey involves multiple bees working in sequence, and the efficiency of that chain depends on one thing above all others: the ratio of foragers delivering nectar to the processing workforce behind them. If forager numbers are high relative to receiver capacity, the chain backs up. Returning foragers wait at the entrance with full loads because no receiver is available. The system loses efficiency at the forager end. But if nurse bee numbers are high and forager numbers are proportionally low, which is exactly the condition Farrar documented in his larger colonies, the chain has the opposite problem. There are plenty of processing bees, there are not enough foragers supplying them. The chain sits underloaded, the supers sit quiet, and the colony that looked strongest all spring ends the flow with lighter boxes than a smaller, better balanced colony that had its forager proportion correctly sized to the work available. The question is not how many bees, it is how many working bees. Here is the specific ratio Farrar kept returning to in his documentation. Colonies maintaining a forager proportion of roughly 50 to 60% of their total population during active flow produced substantially more surplus per bee than colonies where that proportion had fallen below 30%. The 60,000 bee colony with 30% foragers had 18,000 bees working the forage. The 22,000 bee colony with 55% foragers had 12,000. The difference was not large in absolute numbers. But the smaller colony was not carrying 40,000 mouths that needed feeding without contributing to the supers. Its idle load was proportionally far lower. Its stores were being consumed by a workforce that was mostly producing, not mostly waiting. That is the efficiency ceiling Farrar identified. It is not a fixed number. It shifts with the season, with the strength of the flow, with the timing of brood cycles. But it is real, it is consistent, and it is still operating in every apiary where a beekeeper is counting frames of bees and wondering why the results don't follow. The diagnostic habit Farrar's Ohio beekeepers developed from this research did not require new equipment. It required a different sequence. They watched the entrance before they opened the hive. Not once, casually, systematically, at the same point in the morning, over consecutive days during the flow window. What they were reading was forager traffic, not just how many bees were coming and going, but the proportion of visibly loaded returning foragers to total entrance activity. A colony with a well-balanced forager ratio produces a characteristic entrance pattern during an active flow. Returning foragers are loaded, moving purposefully to the entrance, and the traffic is dense and directed. Departures are constant. The hum at the entrance carries a particular character that changes when forager traffic is genuinely high. A colony carrying a large idle nurse surplus produces a different picture. Traffic may be high because the population is high, but the proportion of visibly loaded returning foragers is lower. Bees cluster near the entrance without departing purposefully. The entrance looks busy. The character of the business is different. This is not a precise instrument. It is an observation skill. But it is the kind that opens the hive only confirms or contradicts. And a beekeeper who has learned to watch the entrance first is working in the sequence that Farrar's Ohio beekeepers found most diagnostic. Inside the hive, the sign of an idle nurse surplus is not difficult to find once you know to look for it. Clusters of young bees, pale in colour, unscaled thoraxes, moving slowly between frames, gathered where there is no brood. In a standard Langstroth box, this looks like bees occupying the upper corners of the brood box or the lower frames of an empty super, sitting without apparent purpose. In summer, during a dearth between flows, this is so common that most beekeepers treat it as normal. Farrar's interpretation was different. Those bees are present, they are eating, they are not producing. And in a colony that has crossed the efficiency ceiling, their presence in those numbers is telling you something about why the honey boxes are lighter than they should be. The beekeepers who understood this in Farrar's Ohio could not accelerate a biological clock. What they could do was carry the question forward into the following season. Not how large will this colony be at the flow, but what will its forager proportion look like at the moment the flow peaks. That question, applied weeks before the flow rather than during it, is where the management leverage sits. The surplus is not determined during the flow. It is determined by the demographic composition of the colony that enters it. The weight of that lighter super. Most beekeepers have felt it. The colony you were watching all spring, the one that went into the flow with more frames of bees than anything else in the yard. And then the harvest, and the question without a comfortable answer. Farrar spent 11 years finding that answer. It was not genetics, it was not the forage, it was not bad luck. It was that the colony's population had grown large enough that its internal demographics had quietly shifted away from production and toward maintenance. More bees, consuming more stores, waiting out biological clocks in a phase the flow never had a chance to overcome. He documented it. His data held across seasons, and the explanation was quietly set aside because it had nothing to sell. It required no treatment, no purchased queen, no replacement package. It required a different question asked at the hive entrance before the inspection began. The question is still available. The entrance is still there. The efficiency ceiling Farrar identified is still operating. It will express itself again this season, in colonies that look strong right now, and will produce lighter boxes than their population suggests they should. More bees is not more honey, it is more mouths. If this kind of forgotten precision changes how you read a colony, subscribe. There is more ahead.